And welcome everyone. So this video is going to be a walkthrough of the solution to the exam in economics of entrepreneurship. There are 4 questions on the exam. I'll show these briefly here. So here's the first one. And like if you didn't take the exam and you'd like to practice it, or if you want to remind yourselves of the question, if you did take the exam, pause the video real quick. I might put this on my Substack. It's just that this type of exam with so much LaTeX actually kind of gets a little bit annoying to put onto Substack. Maybe I'll do that. If I do, I'll link up where that appears. One big issue is I don't have a separate Substack publication specific for economics of entrepreneurship. I would probably just put this in my microeconomics place. Okay, that question right there had a table. Here's the tables that you need. If you're planning on trying the exam right now, you probably want to take screenshots of this so you have the tables to look at. All right, and then there's 2 more questions. This is all that there is on this question, so I'll just scroll right down. There was no part C. And then this question right here, well, I had lots of room. And then this is the, let's say, fun part of the question is this one right here. Okay, so that's the exam. Let me just switch over to the solution part. We'll do that now. The first question, this was reminiscent of the Excel, Stata, R exercise to use simulated demand like you might have for survey data to estimate a demand curve. And the key thing you had to remember from that is just all right, if we have our regression results, here's our intercept, here's the coefficient on price, and then we can write down our demand curve. I told you the dependent variable, it's the estimated quantity demanded. And so hopefully that lets you recover the demand curve pretty quickly. So that's use the regression output. I even said it there. Use linear to give us the linear demand equations for each product. Then for each of the 2 products, we want the profit maximizing price and quantity. Then we want to calculate profits in the 2 scenarios, and we want to determine which they should specialize, if any, right? Okay, so here's our 2 demand curves. This is just from recovering the coefficients. This was the intercepts, and then the slopes on price in both cases was 200, right? My coefficient on price was 200 in both places. So here's my 2 intercepts. And there's my respective demands for sandwiches and for smoothies, or smoothies and for sandwiches. Then we need the profit maximizing price and quantity. Remember the expression I gave us for profit in class? This is actually how I teach it in Econ 101 as well, which is it's nice to write out profit as price minus average total cost or price minus marginal cost. In this case, since we have fixed costs, it made sense to write it this way. So this is P minus MC times Q. And it doesn't look like it from how I wrote it here, but this is indeed, just think about it for a second, price minus 1. That 1 was our variable cost. It's going to be your marginal cost. That's per unit, so it'll be a marginal cost. Remember, marginal cost comes from the variable cost portion of total costs. And then here's the sandwich variable cost, 180 per unit. So that's where that is coming from. Okay, this is just Q because that's the demand. You'll evaluate that at a specific price, and it's going to give us a quantity. And then 300 was our fixed cost. Okay, so then what we need to do is take a derivative with respect to price here, because price is the variable that we've got. So we could do that a couple different ways. One thing we could do first is we could expand, we could distribute first, and then we could take the derivative, or you could take the derivative using the product rule. If you do that, this is the first, and this is the second. So it's the, derivative of the first times the second. So the derivative of this first thing is just 1 times the second term was 1200 minus 200 times price. Then it's going to be the first, price minus $1 in this case, times the derivative of the second, which is minus 200. So that's what this is. So that's all that is. This was just using the product rule. Now, you didn't have to do it that way. Lots of people expanded this and then took a derivative. That's just fine. I always like doing it this way because that way I can be really careful about minimizing the chance for a sign error. But anyway, then it's a matter of collecting like terms and then solving for P. Remember, we had taken a derivative, so this is all equal to 0. And then this price solves our first order condition for our maximum. All right, with that price, we can go to the demand curve. We can find the associated quantity demanded. That's our candidate profit maximizing price and quantity. To verify that this actually is profit maximizing, we better calculate profit and make sure that it's positive at least. So here I just went right back, and so this is going to be this was the quantity times $3.50 minus $1. That's the price minus marginal cost part minus the fixed cost. Okay, $950. We did something really similar for sandwiches. Again, this is price minus marginal cost times quantity minus 300. Distribute everything, and then solving our first order condition, you'll get 4.275, right? You could round that to 4.28. That didn't matter. I mean, generally speaking, I say like it's best not to round too early. Also, like usually I want you to work with fractions. This is like a horrible fraction, so didn't need to work with that one, I guess. But in any case, you'll calculate a quantity of about 495, or a little bit less, a little bit more, depending on if you rounded this. That was fine. And then you'll calculate profits. It's going to be 925. Okay, so you had higher profits from smoothies, so you'd want to specialize in smoothies to have higher profits would be the recommendation. Though you might actually you might have considered you might have like a more full response than necessarily just comparing the profits here. I mean, there's maybe some other considerations. We have to make some assumptions about smoothies and sandwiches, and whether the fact that we sold this many smoothies and sandwiches reflects any complementarity between them. Like maybe people are buying both of them, so maybe our profits when we sell only smoothies is less than 950 because people only want their smoothies when they have a sandwich, or maybe it's reflecting substitutes. I don't know. So that was good if you discussed that kind of level of detail, but I didn't say that it was fine if you didn't. So just had to come up with your recommendation basically. Okay, so the next one was pickleball lessons. This has 4 questions. So first, you're charging a single price, not yet paid the first fixed cost. What's going to be the optimal price and quantity if you maximize profit? Second, you're going to move to table 2. So now we've got rivals that are discounting, so our demand decreases. So we want to know what's the price and quantity if we want to maximize profits. Then at the end of June, well, we're going to be stuck with our more pessimistic demand, so we're still going to be using table 2. And then in part 4, or part D, what if you're able to price discriminate? So now we have our horrible demand curve, but what if we don't have to be restricted to just MRMC? And so then what do we do? Okay, so we go to the table. Here's the table for part 1. Part 1 is just like we want to find our profit maximizing price and quantity, right? So to do this, we're going to compare marginal revenue to marginal cost. And we'll find our profit maximizing price and quantity by looking to see where's the point where marginal revenue stops being bigger than marginal cost. Okay, so it's like at 11, because at 11, marginal revenue is 42, marginal cost is 40. But if I go to the 12th unit, now marginal cost is 42, but marginal revenue is only 40. Okay, so my candidate profit maximizing quantity and price is going to be 11 and 52. But we have to actually verify that we're making positive profits. Otherwise, our actual solution is going to be 0, and then our profits are going to be a loss of this 100, which is our fixed cost. Okay, so then we also have to verify, is 52 bigger than average total cost of 42.73? Yeah, it is. So we're fine. Okay, then we go to table 2. This is the less optimistic, the more pessimistic demand. We're going to compare marginal cost, marginal revenue again. It turns out the profit maximizing price and quantity, well, if we're comparing marginal revenue, marginal cost, it's going to suggest that it's 8, right? Because marginal cost is 34, marginal revenue is 35. The next unit, it's 33, but it's 36 as my marginal cost. Okay. But we can't immediately say that we definitely want to produce 8. Maybe we're better off just producing 0 and losing, so we'd lose 100 or 110, depending on, I guess, kind of how you'd read this. So I kind of screwed up my table a little bit, but okay, fine. So because we wanted a quantity of 0, we want everything to be fixed cost, and we want it to just be 100 here because there shouldn't be a variable cost. But okay, so whatever. We're going to compare our price of 42 to average variable cost because that's the short run comparison. It's higher than 32, so yeah, we'll keep producing in the short run. However, 42 is less than 44.5, so we're going to definitely shut down in the long run. That's why the comparison is necessary, because if the average variable cost was any higher, well, if it was 10 higher, we wouldn't want to produce at all, right? So it's not a foregone conclusion that the profit maximizing price and quantity is 8 and 42, just because that's where marginal revenue equals marginal cost. Oh no, we also have to check price versus average variable cost, and then price versus average total cost. Because then, what if we end up having this in the long run? That was part C. Well, now we definitely want to shut down because, so our candidate maximum was quantity of 8 and a price of 42, but that is less than our average total cost. And then actually, if you look at this carefully, it turns out average total cost is everywhere higher than my price. So it turns out there's absolutely no place where we can be profitable as a single price monopoly in table 2. And then we say, well, what if we're able to use price discrimination? Then you actually can operate, because it turns out if we price discriminate, now we disregard this last column. That's no longer our marginal revenue curve. Now the marginal revenue curve is our demand curve. That's price right here. So we find where price is, we'll compare price to marginal cost, and where price stops being bigger than marginal cost is where we're gonna is going to be the last unit that we'll sell. So let's see, price is bigger than marginal cost, all the way down to, let's see, bigger here. Price is bigger at 10, but marginal cost is bigger than price at 11. Yes, we'd want 10 right here. We're going to sell the first unit for 49, second unit for 48, then for 47. You just had to describe that basically and say that you'd stop where price equals marginal cost. And the last thing you have to do, honestly, is like you have to prove that it's profitable. So you want to add up 49 through 42 and show that that's bigger than your total cost of 40, bigger than your total cost of 430. And it is, you're better off producing. So that's what this write-up here now. So in the solution here, now let me just kind of like written out, show what I said. So the optimal quantity was 11, optimal price is 52. That was the reasoning, was just MRMC reasoning. But then we also have to show price exceeds average total cost, right? Otherwise, we'd rather shut down. In part B, we saw the candidate solution was 8 and price of 42, but we have to check, is price bigger than average variable cost? Otherwise, we'd actually rather shut down. It is, even though price is not bigger than average total cost, which means, yeah, for part B, we'll keep producing rather than lose the 110. Let's just go with the number I had in the table. But then what about part C? Well, part C, if we're in the long run, price is not bigger than average total cost, actually there at our candidate solution or anywhere else in the table, right? So that's a big problem. Then for part D, this is price discrimination. So perfect price discrimination, 49 to person 1, 48 to person 2, all the way down to 40 for person 10. And then you just have to sum up your total revenue and sum up all those prices to give you total revenue and show that that's bigger than 430. Because it could have been that it's not even profitable to perfectly price discriminate, like if demand was really, really low. So you have to check both things. The optimization step involves two things. One is identifying like what's the optimal amount to produce and what's the pricing strategy. And then part two is justifying that actually is profit maximizing. It's kind of like in, if you want to find the local max or local min, you find the derivative to get your first order condition, but you also have to check the second derivative to know that you haven't found a minimum when you thought you found a maximum. Okay, so the second one, you're an analyst giving the task, or with the task of assisting optimal pricing for different versions of a meditation app. I meant for that to be like pretty straightforward, that you're only going to ever subscribe to one version of the meditation app, but I actually did say it right here. Consumers are going to download at least at most one version of the app. You have two different types of consumers, 100 of each type, and we've got our willingness to pay right here. I think originally, originally on the exam, I swapped these, and then on this version, I already fixed it, I think. So we wanted low here. Of course, it's got the smaller willingness to pay numbers, higher willingness to pay numbers here too. But anyway, so what do we want to do for part A? Well, we're going to sell just one version of the app, which is going to be our price. Okay, so there's two candidates. One is we could sell the low version at a price of 8 and sell it to 200 people. Or we could sell the low version at a price of 10 and sell to 100 people. Or we could sell the high version at a price of 12 and sell that to 200 people, or the high version at a price of 20 and sell to 100 people. It turns out it's going to be the same whether you set the price of low at 8 and sell to 200 people, or set the price of high at 20 and sell only to 100 people, right? And so this would be only selling low quality, or only selling high quality. Then for the second one, we say, okay, we can support both versions of the app. Which pricing scheme are we going to use to maximize profit? This is second degree price discrimination. We're going to set prices that all of our consumers are going to see. And then they're going to self-select into which version of the app is right for them based on the pricing and how it aligns with their willingness to pay. So remember, the two problems we want to avoid is we don't want one of our groups, particularly the low group, to get discouraged from buying in the first place. So we want to set the price that they're going to buy. So the price of low is going to be 8, right? I think everyone got that. And then we want to set the price of high such that we incentivize our B consumers to buy the high version. And the problem is they're going to see that price quote of 8 for low, and they're going to get a consumer surplus of 2 because they would have paid 10. We're going to ask them to pay or 8 if they buy the low version. So we have to make sure that they get at least a consumer surplus of 2 if they buy the high version, which means we can't set the price of high at 20 because their consumer surplus would be 0, and they'll surely buy the low quality version because they'd rather have a consumer surplus of 2. So instead what we want to do is we want to set the price of high at 18 or like $17.99 or something like that, right? And so that's what I said right here. And actually you can calculate then our profits are going to be higher. It's going to be $1,600 rather than $1,200 if we use this policy. And so what did I say? You could set a price of 18 or $17.99, not 17 or lower. And the reason why is you don't need to go all the way down to 17 or 16 or anything like that. That sacrifices profits unnecessarily. And what we're trying to do is what's going to be the pricing scheme that maximizes profit. It's not just like find a pricing scheme where both are going to buy their intended version of the app. We want that for sure, but also we want to maximize profits. Also, it could have been that even that version, or it could have been that the costs of us producing the high quality version were so high that we might actually not want to do it. So you actually have to, that's why it was important to calculate the profits and show, yeah, 1,600 is bigger than 1,200 where we only sell one. Okay, so the last one's a two-part tariff question. We've got two different segments of demand. So price is equal to 120 minus Q and price is equal to 180 minus Q. We have constant marginal cost of 30, no fixed costs. The first one, this says you've got the unusual fortune of being able to distinguish between customers. So you should immediately realize, oh, wow, we can just sell the ideal tariff to each of these separate demanders, as though we had like identical demanders, because we've got two separate groups of customers that we can, maybe with like third degree price discrimination, we have like a student discount because you've got your student ID, or children versus adults at like at a zoo or movie or something, whatever. So the idea is we have two different types of customers and we can condition their membership fee on what type they are. Okay, so basically then the solution just amounts to let's find consumer surplus at the price of marginal cost respectively in each group, right? So because if you have the ideal tariff, if you have just one group of demanders, like a homogeneous group of demanders, set price equal to marginal cost and then find consumer surplus, and that becomes the access fee. So that's all we did here. So I said we can treat the two groups completely separately as if each is a distinct homogeneous market, set price equal to marginal cost of 30 in both cases, find the associated tariffs for the two group. So in one group, remember the area of consumer surplus here is going to be just a triangle. So it's 1/2 base times height. The 120, that's like the vertical intercept of the inverse demand curve, minus 30 for marginal cost. And we actually get another one of those. That's why it's squared, because demand is going to be, right? If we solve this for Q, we'd get demand. Q is equal to 120 minus P. We're setting a price of 30, so Q is equal to 120 minus 30. So we get this squared. I wrote this out rather than just 90 squared so that you kind of see a little bit of the work. Okay, so that turns out to be 4,050 from our low group of demanders. For the high group of demanders, basically the same process, only it's going to be 180 minus 30 squared. And your profits you'll get from them will be 11,250. So total profits are 15,300, right? So that's going to be at the end of the day, what are our profits? 15,300. Okay, so part B now, we want to assume that we have the same demanders, but the key thing here is the restriction is they both have to receive the same two-part tariff, so the same fee and the same per unit price. Okay, so this is where we want to write out profits as a function of price, and then we want to take a derivative. We want to find the optimal price, and then with that price we can drop that back into our expression for consumer surplus for our low group, which is going to be our tariff, and then that'll give us our tariff profits. And then actually, like, to be sure, you should go back and compare this to profits if you were to just ignore one of the two groups, and that's interesting to do in this one. But anyway, so for this one here, what we're going to do is we're going to write out profit as a function of price. So this is 2. Why 2? Well, we have two consumers. And so I'm going to get tariff profits, that's this right here, based on the consumer surplus for the smaller group. So I'm swapping out 30 for P, or P for 30 right there. Okay, then it's going to be my low demand times price minus marginal cost plus my high demand times price minus marginal cost. You could distribute this, or, the easiest way to do this is probably first to factor out this price minus 30, and then you'll have, 300 minus 2p, and then you could either FOIL or you could take a derivative. But I just took the derivative from this line directly. So, first I canceled the 2 and the 1/2. Then it's going to be chain rule right here. So it's going to be 2 times the quantity 120 minus p. And then, so it's derivative of the outside times the derivative of the inside. The derivative of the inside here is going to be -1. And then this right here is going to be, let's see, the first, which is 120 minus p, times the derivative of the second, which is just 1. Oh, my contacts are really bothering my eyes. Sorry. And then this is going to be the derivative, then it's going to be the derivative of this -1 times the second. And then the same thing over here, 180 minus p, and then times the derivative here is just 1, and then the derivative of the second one right here, or the first one, is -1 times price minus 30. Okay. Once you do that, collect like terms, you'll solve and you'll get a price of 60. So that's going to be our optimal price. You'll drop that back into here to calculate the access fee. So into this part right here, or actually just like this expression, you drop in 60 instead of 30, so you'll get 60 squared. Half of 60 squared, right? And that gave us the access fee of 1,800. So profits are going to be, we'll get that twice. We'll get that from each group. And then here's price times, this is 60 minus 30 is 30. And then this is, let's see, 180 minus 30. No, 180 minus 60 is 120. And then here's 30. Yep. And we calculate profits of 9,000. Okay, so basically though, all you had to do is you had to have the price equals 60, and then you had to calculate the tariff access fee. What you really should do then is compare this to the situation where you can ignore one group or the other and see if profits are higher. But you have to do this work anyway to then compare to that situation. Okay, anyway, so go ahead and conclude here. Hope you enjoyed the video, and I will see you next time.